Getting to the network service mesh. So step one is a network service registry. So in Kubernetes, for Kubernetes services, you have a registry that lists out the services and their associated endpoints. Clearly, for network services, we're going to need an analogous registry of network services and network service endpoints. First, let's have a totally separate kind, a different resource, so we don't screw up what works for the guys in Kubernetes for services for applications. Give it a name. Have a selector that will match a pod that provides this network service. And then here's where we deviate in the first point. Rather than having a thing called ports, we'll call it channels, to avoid the infinite overload of the word ports in networking. Now, a channel is something that accepts multiple connections with a payload type IP, Ethernet, MPLS, whatever, and it provides a particular handling of that payload. It fills whatever the contract of that service is. Now, the second point at which we deviate is instead of having protocol, we have payload. Now, we do this because we want to focus on what's carried over the channel to avoid baking in the tunneling mechanism. Because if I have an IP packet or an Ethernet frame that is my payload, in networking we have many ways this could be gotten from one pod to the pod that provides the network service. And we don't want to bake that into the service description. We want to let the infrastructure work that out. So network service discovery and routing. A pod requests a connection to a network service, and it sends an IP, it sends a payload, either IP or Ethernet or MPLS or whatever, over that connection. And that connection should be routed by Kubernetes to whoever's providing the network service, possibly using load balancing under the covers. Now, please note, when I say it gets it there over a connection, this is whatever mechanism is used to transport that Ethernet frame or IP packet. This is never going to be riding on top of TCP. It's going to be something like VXLAN, VXLAN GP, MPLS over UDP, etc. As it turns out, if you were a pod, the internet is a series of tubes. Now, those tubes might be the sockets at the TCP layer that you're shoving different streams across. Or if the thing you're interested in is L2 frames or L3 packets, it could be an interface or some other interface substitute like memIF, vhost user, etc. And so here we just generalize all that into the concept of a connection between a pod and a network service implementation. We're in a greenfield situation. We can introduce a network service manager running as a daemon set, so it runs on the same node. And then when a pod wants to do service discovery, it can send a service discovery request or expose a channel or request a connection by sending those requests to the network service manager. You want to send those over gRPC, over a Unix file socket mounted into the pod. And then the network service manager injects the requested connection or channel into the pod. Effectively, in this case, the network service manager becomes our proxy or sidecar here. We use a completely unmodified device plugin API. When you deploy your pod, you request an NSM as a resource. Then you go through normal pod deployment. The pod is scheduled to a node that has an NSM available. The device manager carries out the allocate step. And one of the things that comes back from that allocation is the mount point for the NSM file socket. And then you run the pod normally, and the NSM file socket gets mounted as is normal for the device plugin. Let's run through a really simple example of how pod-to-pod connection setup would work for network service functions. If I'm a pod over here on the right that exposes a channel for a network service, I would inform my NSM. The NSM goes and adds a network service endpoint up at the API server so that we now have the network service endpoint indicated. And then when a pod on a different node requests a connection to that channel on that network service, it goes through and figures out from the network service endpoints where the NSM is that is managing a pod that provides this and makes a selection. Having made that selection, it sends a request connection to the NSM. The NSM sends the request connection to the pod, so the pod knows that it's going to be getting a new connection. This allows the pod the opportunity to refuse. If the pod accepts the connection, the NSM injects whatever interface, memIF, vhost, etc., goes into the pod. And the NSM then accepts the connection to the originating NSM, which injects the interface, memIF, vhost, whatever, into the pod, and tells it that its connection has been accepted.